Hi guys, welcome to my YouTube channel, and let's look at this problem that is before us. So guys, we are going to solve this problem, and it is a derivative question. So let me read it. Find dy dx from first principle, given that y is equals to tan x. So guys, let's look at this problem, and the answer that we shall get is this. In fact guys, even when we are not given the answer, we can now even look at the tables, and when you look at the tables, mathematical tables, you'll find this answer. And so the answer is not hidden from us. So what we require is to know how to do it from first principles. And for us to do that, we write the equation that we are going to use. And this is the equation. We'll have f prime x. That means the derivative of x. Derivative of x is going to be, derivative of x in our case is derivative of tan x. So guys, I can even write here, maybe I can write derivative of tan x like that. So this one is supposed to come to is limit, we write here limit h as h tends to 0, f x. For the general solution, this is the general solution guys. Now we can maybe put aside this one first. Now this is the general solution, that is f prime x. We usually have fx plus h minus fx all over h like that. So that is the general solution guys. Maybe I can even write it here better so that we can see it again. F prime x is equal to, this is equal to, equal is supposed to be there, equal to limit as h tends to 0, fx plus h minus fx all over now h. So that is our equation guys. And so we can now start to solve the problem. And so guys, for tan, we can write like this, f prime tan x like that. This one now is going to be limit h tends to 0. Now we can write in terms of tan here. Instead of even writing now f, let's now write in terms of tan. So this one is going now to be tan x plus h like that minus tan x. This is the original value the way it was, and this one x has been added, h has been added to x all over h like that. So guys, we continue. So we are going to do like this guys. We're now going to change, because we know that tan x plus h, this one is the same as cos sine x plus h all over cos x plus h, like that. So we are going to change that. And also we know that tan x, can also put here tan x is equals to sin x all over cos x. And so guys, using that, can come and transform our equation now. So we shall have f or derivative of or d tan x all over dx, like that. This one we say now limit as h tends to 0. Now we shall have sin x plus h all over cos x plus h minus sin x all over cos x, like that. So guys, now maybe we can deal with this one first. We can do away with this one for some time, but then we are going to bring it back. And so guys, we shall write like this. We shall come here and now do this. And remember we have h. Guys, we have h. I can maybe put it somewhere here, 1 over h. So I can now expand that. In expanding that, I can draw a line here. So we find the LCM of that, cos x plus h and cos x. Cos x plus h, cos x, you divide that by that, you get cos x. So this one is going to be sin x plus h multiplied by cos x. So you need to extend, and this one you can also write h there. Then this one is now going to be minus. You divide this. Guys, we are not dealing with h first. We are now dealing with that. H we shall still come and put it later. And so we look at that and cos. That one will give us cos. We start now with the cos x plus h. You multiply by sin x. So that is what we have, guys. So as I have said, guys, for h we shall deal it with it later. So now we look at this. We look at that and that. So guys, when we look at that, we see something, and that is the trigonometric identities. Remember that if we have something like this, guys, let's say sin theta minus phi, this one gives us sin theta cos phi minus sin phi cos theta. Remember that equation, guys. So this equation is not part of this, and so I can maybe even surround it like that. That is to mean that, guys, we just have to remember that. If you look at that, guys, you look at this, you find that there we have sin theta cos phi minus sin phi cos theta. So, and if you check at this, you find that this value is like the one which is now sin theta. It's like it is theta, this one is phi. Because when they come here, they exchange. Just like these ones have exchanged theta and phi. And so we can actually say our theta, if we give our theta to be x plus h and our phi to be x, then enlighten this, that is transforming this to this form, then we shall have sine x plus h, which we are calling our theta in this case, minus our phi then would be x, like that. That is how now we could do. Because if you expand this one, guys, you will get something like that. And so, guys, when we do that, then we are able to transform this into this format. And this one, guys, gives us sine h. So because x minus x is x plus h minus x is sine h. And so, guys, we shall have something like this now. We shall have sine, that is for the numerator, we shall have sine h all over. Here we have cos x plus h, and down here we have cos x, and still we have the h. We have the h there. So, guys, let's now go back to our original equation and now put the way it is supposed to be done. So we can say d all over dx tan x, like that, because that is the derivative of, we are finding the derivative of tan x. This is equals to limit, we write it there, and then h we write here below. As h tends to 0, sine h all over, guys, let me bring h here, up there. So we now have here cos x plus h, and here we have cos x, like that. So, guys, with that, from what we call derivative from first principles, limit as h tends to 0, sine h all over h. This one is usually 1. So, guys, this is now going to be 1. And because of that, guys, then we will say d all over dx tan x as is equals to limit as h tends to 0, 1 all over cos x plus h cos x. This one now, guys, is going to be, because now h is tending to 0. So if it tends to 0 here, guys, then it means this is going to be cos x. Why do I say like that? It's because whatever value here there is, and this one is almost tending to 0. It's like adding a big number to a very small number. So what you get is almost that big number. And so therefore, guys, our values then are going to be d all over dx tan x, that is the derivative of tan x, is going to be equal to limit as h tends to 0, 1 all over, now we neglect that h, so we'll be left with cos x, which is now equal to 1 over cos squared x, like that. And 1 over cos squared x, guys, this one is the same as the secant squared x. And so guys, this is our solution. So guys, thank you for listening to me. Bye bye.